We are now going to continue with the calculus, and this time we are looking at stationary points. Now, stationary points are also called turning points on a curve. And the types of stationary points that we have are, we have a maximum point, we have a minimum point, and we have a point of inflection. So these are the three stationary points that we have. And one thing that we have to note here is that there is a condition for stationary points to exist. So stationary points will only exist if dy dx is equal to 0. In other words, we are saying if the gradient is 0 at that point, then we have a stationary point there. It could either be a maximum point, a minimum point, or a point of inflection. Now, here is a question that will help us to find the coordinates of these stationary points. So the question says, find the coordinates of the stationary points on the curve y is equal to 2 over 3 x to the power 3 minus x squared. So here is our equation. Y is equal to 2 over 3x cubed minus x squared. So the first step that we follow here is to differentiate this function. We find dy dx for this function. So we are going to have dy dx is equal to, then we multiply this number 3 times 2 over 3, which will give us 2x, and then you subtract a 1 from the power. So you are going to remain with a 2 there. 3 minus 1 is 2. Minus, there's a 1 here. 2 times 1 is 2. Then you subtract a 1 there. You just have x here to the power 1. And so you've differentiated. Now, when you reach this stage and you're finding stationary points, the condition says dy dx should be equal to 0. So you are going to equate this to 0 now. So you are going to have 2x squared minus 2x is equal to 0. And then you solve for x here. So this is a simple quadratic equation which can be factorized here, because this side you have 0. And then this side you only have a and b. You don't have c. So when you find such a quadratic equation, you can factorize it. So 2 is common here, you're going to say 2 here. X is also common. So this x has a power of 1. So you get the one that has the smallest power, x. And then you open brackets. Here you've removed 2 and 1x. So you remain with 1x here. Minus 1 here. Because all this component has come outside the bracket. So you remain with a 1 there. And this is equal to 0. And then you can solve this simple quadratic equation by separating these two terms here. So you're going to have 2x is equal to 0, or x minus 1 is equal to 0. Here you divide both sides by this number here 2. So you're going to have over 2 here, over 2. So you have x is equal to 0, or, and then here you move this negative 1 and take it to the other side. So you're going to have 0 plus 1, it will be a plus. So our x here is going to be equal to 1. Okay, so now that we have these two values of x, we can now solve for y. Because the question says find the coordinates. So you need the x and the y values. So the equation that we are going to use is the one that we are given in the question. So here, we'll start with this one here. We'll say for x equals 0, we are going to substitute this 0 here where there's x in this equation. So we are going to have y is equal to 2 over 3, where there's x you put a 0 to the power 3 minus 0 squared. So 2 over 3 times 0, because 0 to the power 3 is 0. So we are going to have 0 here minus 0 there. So y is equal to 0. So the first stationary point has been found here. The first stationary point is actually x0, comma, y is also 0. So this is the first stationary point. Now we are going to find another stationary point for x equals 1. Because we found for x equals 0, we substituted here 0. Now we are going to substitute 1 to find the other stationary point. In this equation now we are going to substitute x is equal to 1 for us to find the other stationary point. So x is equal to 1 will be substituted here in this equation. So we are going to have y is equal to 2 over 3, 1 to the power 3 minus 1 squared, which will give us y is equal to 1 to the power 3 is 1. 1 times 1 times 1, you multiply it by itself 3 times. Times 2 over 3, you have 2 over 3 minus 1. And then here you can find the common denominators and evaluate this. So over 1 here, the common denominator is 3. So 3 into 3 is 1, times 2 you have 2. 1 into 3 is 3, 3 times 1 is 3. And so this is going to give us negative 1 over 3 as our y. And so therefore, our next stationary point here is 1 comma negative 1 over 3. So we have our two stationary points. So therefore, the stationary points are stationary points. We have 0 comma 0 and 1 comma negative 1 over 3. So these are our stationary points. And this marks the end of our lesson. Thank you very much for your attention.